Hi, everyone. My name is Robert Haas, and this is my talk on avoiding, detecting, and recovering from database corruption. Just by way of introduction, I am a fairly long-time PostgreSQL hacker. I've been participating on the mailing list for about 13 years now, and this is my first time speaking at the Russian PostgreSQL event. So I'd like to thank the organizers for the opportunity. For my day job, I work at EDB as the chief database scientist. I'm always a little afraid that when I give talks like this, people will start to get the idea that database corruption is something that happens in PostgreSQL all the time. And I don't really think that's true. I think that actually it's a pretty reliable system and most people have a good experience. But because I work at a company where we provide a lot of support to users of PostgreSQL, and because people tend to report their most serious problems to us, I actually encounter these kinds of problems pretty frequently. So just by way of agenda, I'm going to start by giving a quick definition of corruption. Then I'm going to talk about some of the causes of corruption, some best practices that you can follow to avoid having your database get corrupted and to detect the fact that it has become corrupted if that happens. We'll talk about signs that it has happened. And finally, we'll offer a few ideas about how you might be able to recover from the situation if it does happen to you. So in terms of a definition of corruption, the best thing that I could come up with is to say that corruption means that the database contents have been altered in some way. And specifically, they've been altered in such a way that SQL statements behave in a really unexpected manner relative to the other SQL statements that have been previously executed. So, for example, if we store some data into a table using an insert command, our reasonable expectation is that a subsequent select command will return the same data that we stored, assuming, of course, that we haven't modified it since it was originally stored. So if that's the case, and if we get back different data than what we originally put into the database, that is corruption. If we get an error or a crash, that's also corruption, provided that the reason why those things are happening is because of some unexpected alteration to the contents of the database. If that's not the issue, if the database hasn't been altered, or if that's not the reason for the problem, then we might just have a plain old bug. But for this talk, we're going to be focusing on the corruption case. In general, there are sort of three possible ways that database corruption could happen. So first of all, you might have a problem with your hardware, such as your disk or your memory. Secondly, you might have a problem with your software. And thirdly, the problem might be you, the user. You might be doing something that is incorrect. Now, all of these things are pretty common. Disks go bad quite frequently. Memory goes bad much less frequently, but there have been a couple of documented cases during my time at EDB where a customer had a problem with database corruption and it was eventually tracked back to bad memory so that the contents of the database got corrupted even before the data was written to disk. And of course, all software has bugs, or at least all software that's at all complicated has bugs. PostgreSQL has bugs, your operating system kernel has bugs, your file system and your backup tool have bugs. Everything has bugs. So sometimes those bugs may result in database corruption. And finally, people do things themselves all the time to corrupt their databases. Probably one of the most common examples is people who perform backups or recovery from backups in a way that does not match what the documentation says that you should do, and they end up with a corrupted database. But there are a variety of other things as well, and we'll talk a little bit about that as we move through the rest of the talk. So we're going to talk about best practices for detecting and avoiding corruption. Of course, you can't completely avoid corruption, no matter what you do, and you can't be completely sure of detecting corruption, no matter what you do. but there are things that you can do to improve your chances. So I've grouped some of the best practices into 4 areas, and we'll just go through each one individually. So first of all, backup and restore. The most important thing here is that you actually need to take backups, and you need to take them regularly. And there are 2 reasons why this is important from the standpoint of database corruption. I think one of those reasons is pretty obvious, and that is that if you do have some kind of database corruption, but you have a backup which is not corrupted, then you may be able to get your data back from the backup, and in that way you may be able to avoid any sort of permanent data loss. But there's a second advantage to this too, which is that taking a backup basically means that you're going to copy your entire database. And if you make a copy of your entire database, that proves that all of the data is readable. It does not prove that all of the data is correct, that the data that you read off the disk is the same as the data that was written to the disk. But it at least proves that you can read something from the disk, which is not something that you want to take for granted because, again, disks go bad all the time. It's not enough to just take a backup, of course. You also need to make sure that you can restore the backup, and you want to verify that the restored backup looks okay. After you restore the backup, you should check that all of your data seems to be there, that you can run some sample queries against it, and that it looks like you have what you expect to have in terms of the database having the proper contents. If you don't check these things, then they might turn out not to be true. And the time when they turn out not to be true is the time when you really need them to be true. So you should really, test these things on a somewhat regular basis and be sure that everything seems to be working the way that you think it should be working. My final piece of advice in this area, and I think this is really important, is that you want to use a good professionally written backup tool rather than a homegrown script. I am always really surprised by the number of people who seem to be doing their backups and restores using scripts that they wrote themselves. And a lot of those scripts are not very good. I've seen quite a few of these scripts that people have written for their own environment where there are no error checks, which is really bad when you're talking about something that is as critical as taking a backup. Now, if you use one of the various backup tools that are available for PostgreSQL, that doesn't guarantee that you're not going to have a problem. After all, that backup and restore software is pretty complicated, and it too can have bugs, and almost certainly has some bugs somewhere that could affect the integrity of your data. However, it's likely that a person whose job it is to write a backup tool, or who has spent a lot of time working on a backup tool, may have done a better job with it than you would be able to do yourself. Especially if that person is also more knowledgeable about PostgreSQL than you are. And hopefully that backup tool that they've written is in use in a large number of PostgreSQL instances, and therefore whatever bugs it had in the first version, hopefully at least the most serious ones have been found and fixed by now. So I really strongly recommend that you go around and figure out which of the various backup tools that are available for PostgreSQL is best for your needs, and make use of that rather than rolling your own procedure. Moving on to configuration, there are 3 settings in PostgreSQL.conf which have an effect on the ability of the system to survive an operating system crash without data loss. The first 2 are pretty simple because the defaults are safe and you should just never change them. Fsync should always be turned on. If you turn fsync off and you have a crash, you are very likely to end up with a corrupted database. One particular thing that people sometimes do is they turn off fsync during the initial load, hoping to speed things up, and they forget to turn it back on afterward, and then months or years later they have a crash and they end up with a corrupted database. I don't know that it's really worth it. I think you should just always leave this on. It's true that you may be able to improve performance somewhat by turning it off temporarily in certain circumstances, but the performance gains by and large are not going to be that much, and I'm not sure it's sufficient to compensate you for the possibility that you're going to make a mistake and end up with a corrupted database. Full page writes is another setting where the default is on, and you should always leave it turned on. There are theoretical circumstances under which it can be safe to turn this off, and I certainly understand the appeal of that because there can be significant performance benefits from that, but in practice, it's never safe. The theoretical environment where everything uses the exact same page size and all of the writes are atomic is just not a real world scenario that ever happens. And you really need to keep this turned on, or again, you risk having data corruption following an operating system crash. The final PostgreSQL.conf setting that we're going to talk about here is a little bit more complicated, and unfortunately, the default is not necessarily safe. For example, on Mac OS X, the default value of this setting is fsync, but fsync is not actually safe on Mac OS. You need to use the fsync write-through setting. I am not an expert on Windows, but I have been told by people who are that if you are running on Windows, you need to use either fsync or fsync write-through, or disable write caching on your drive. I recommend that no matter how you configure this, you check the output of the pgtest fsync utility, which is included with PostgreSQL. If you see that the method that you have chosen is 10 or 100 or 1,000 times faster than some other method, then there is a good chance that it is not really working. We rely on fsync forcing all of the dirty data out to the disk, and if it doesn't do that, then you may end up with a corrupted database in the case of an operating system crash. There's one other piece of configuration which is not part of PostgreSQL.conf, but which is really useful if you're concerned about the possibility of database corruption, and that is the checksums feature. Turning on checksums won't prevent your database from becoming corrupted, but the corruption is much more likely to be automatically detected and to produce errors that you can notice. So if you want to use this feature, you can create your database cluster using initdb-k, or if you're running version 12 or any newer version, you can shut down the database, use the pgchecksums-e command to enable checksums, and then start the database back up again, which will be quicker than a full dump and restore onto a new database cluster, which would be another way of getting checksums enabled. There is some performance overhead from this. It's small on most workloads. It could be larger on your workload. So you will want to check and see if that's a problem for you. But it's really nice in terms of being able to spot potential corruption. The big picture in terms of the storage for your database is that you want your storage stack to be as simple as possible. If you can, I recommend that you use local storage rather than a network file system. Certainly, there are people who have NFS and iSCSI configurations which have been expertly configured, and those systems are probably quite reliable, but people who have set them up poorly and end up with something unreliable seem to be pretty common. I think that the simpler you make this, the fewer things there are that can fail. You're always going to have the disk itself, the disk controller, and the various operating system components such as the kernel and the file system, which can do something wrong and corrupt your database. But as soon as you are talking about a network file system, you have multiple servers involved, and each of those servers has a network card that's involved, and there may be a router or a switch involved. And on one of those systems, at least, you still have a disk and a disk controller and all of that stuff. Similarly, when you add things like virtualization or containerization, you're making the process by which the data that you write gets out to the disk more complicated. And every time you do that, there's a possibility that something stops working. So if you use those kinds of technologies, you really need to test carefully to make sure that you haven't broken the reliability of the system. If you do have to use NFS, you should perform the NFS export using the sync option, and I recommend that you perform the NFS mount using the v4 hard and sync options, and that you test it carefully. I do think that using RAID is a good idea. RAID 10 is a great choice for databases. You don't want to rely on RAID not to fail. And like anything else that you add to the system, it is adding complexity. So there is some risk there because your RAID controller can fail just like your disk controller can fail. But that having been said, the really nice thing about RAID 10 is that for every disk you have another disk that is supposed to contain exactly the same contents as the first disk. And so if you find out that that's not the case and that a particular disk is unreadable or contains something other than what it should contain, that it's corrupted in some way, you can just take that disk out and you should still have a working system. You should still have a complete copy of your data. And that is a very nice place to be. There is a good deal of difference between the various file systems that are available in terms of reliability. My experience is that ext4 and XFS are extremely reliable and that almost everything else has problems. ext3, which fortunately is no longer in widespread use, had a lot of problems that affected the reliability of the system. And I've seen multiple cases where bugs in ZFS corrupted customer data, and it was very clear that the problem could only be explained by ZFS having, at least one bug, if not several. So I am very cautious about the idea that it's okay to use some other file system with PostgreSQL. Of course, it may be, and it's up to you. But I think the advantage that ext4 and XFS have is that they're extremely widely deployed. And because they're extremely widely deployed, they seem to be better debugged than many of the other systems. So even though they might be lacking some feature that you really like to have, you have to consider the advantages of using something that a lot of other people are using and that is known to be quite stable. Finally, with regard to storage, you need to monitor both the PostgreSQL logs and also the operating system logs for storage-related errors. If the operating system kernel detects something like an I/O error and it reports that to PostgreSQL, then PostgreSQL is going to log that I/O error, and so you will see that show up in the PostgreSQL log file. However, sometimes the operating system will detect a problem, but it will not report it to PostgreSQL for one reason or another. For example, it might be a soft failure. It might be something like, the data was eventually successfully written to disk, but several retries were required. If that happens, it probably means that the disk is not in very good shape, and that may get written to the operating system log, but because the operation succeeded, no error will be reported to PostgreSQL, and therefore, if you just look at the PostgreSQL log, you will not know that there is a problem. Finally, administration. I feel a little bit silly having to give this piece of advice to everyone, but experience has proved that it is an absolutely necessary caution. Please do not modify the data files in the PostgreSQL data directory in any way, except by letting Postgres modify them for you. In particular, do not remove files manually from anywhere in the data directory. With the exception of a couple of text configuration files like postgresql.conf and pghba.conf, all of the files in the PostgreSQL data directory are intended to be managed entirely by the database system. For example, if you look at the files that are in pgwall, or in older releases pgxlog, the system arranges to automatically remove those files when it believes that they are no longer needed. So sometimes a user goes in and looks at them and says, well, I don't think that file should be needed, and I'm going to remove it. And very often the result of that is the user ends up in a bad situation because PostgreSQL wants to remove that file just as much as the user wants to remove that file, but PostgreSQL is following an algorithm to determine whether or not that file is needed. And if that file is there, it is probably because PostgreSQL thinks that that file needs to be there, and you can't just remove it. So if you see files accumulating in the data directory that you don't think should be there, you really want to try to work with the database system and figure out why it thinks that those files should not be removed and convince it that it actually should remove those files. If you just remove them, you're likely to end up in trouble. I gave this talk, I've given this talk a couple of times previously, and I got a lot of questions about this particular point. A number of people came up to me after I gave the talk and asked me about ways that they had modified the PostgreSQL data directory. And so I found out even more unsafe things that people are doing. So I wrote a whole blog post based on that conversation or those conversations. And I put the link here on the slide in case you're interested in reading more about this topic. A closely related point is that you should not run antivirus software on your database server. If you absolutely have to run it, at least exclude the PostgreSQL data directory, but understand also that that may not be good enough because the antivirus software does not necessarily totally ignore that directory just because you put it in an ignore list someplace. When you really think about it, antivirus software is kind of a surprising thing. Its job is to remove viruses, which means that its job is to modify somebody else's files. And it also quarantines infected files, which basically means removing them. So here you have a piece of software whose whole job is to modify and remove files that belong to other programs. And, PostgreSQL is just not going to cope with that. It expects that it is managing those files and that they're not being randomly modified by other processes. Another thing that you should not do is remove the postmaster.pid file. If you do, you might find that you're then able to get multiple copies of PostgreSQL to run at the same time on your data directory. And if that happens, then you will definitely end up with a corrupted database. And finally, and going back to a couple of the points that were made on earlier slides, a really good idea is to perform plug testing. In many cases, a modern PostgreSQL deployment is going to involve a number of different components. And you can pull the plug on any one of them or any combination of them or all of them at the same time. And, it's good to run some experiments here and see what happens. You want to find out that if you repeatedly remove the power from your database while it's under load, nothing terribly bad seems to happen and your database doesn't seem to end up getting corrupted. If you just test it while the system is idle, you're probably not going to find out very much. If you test it under load, you have a better chance of discovering some problem that will cause database corruption in your environment, and then maybe you can do something about that before it hits you for real. So let's suppose that we did our best to avoid database corruption and that we also did our best to detect database corruption. And now we want to know whether we actually got any database corruption. The good news is that in most cases, you're going to see errors in the log if your database is corrupted. That's not necessarily true. There are certainly situations in which you don't get errors, but you still have corruption. But it's very common to have errors in the logs as a result of corruption, and that's often how the problem is detected. Unfortunately, there's a lot of different errors that you could get depending on the exact nature of the problem. But in general, what you want to be looking for is errors that seem to be complaining about things which are internal to the database rather than user-facing things. I'll give a few examples of those kinds of error messages in just a moment. If you don't get errors, you could see other kinds of symptoms that might also indicate corruption, such as crashes or wrong answers or infinite loops. And those problems can be hard to diagnose because it's easy to get confused about whether the thing that you're seeing is just a bug or whether it is actually the result of some kind of database corruption. But if you get an error, it'll probably look something like one of these things. This is just a short list of examples. It's not intended to be comprehensive. We could go on for pages and pages and pages with other messages that are different from the ones that are shown here. But I think this is enough to illustrate the basic theme. You might get an error message like, could not access status of transaction 3881522, or could not read block 123, or failed to re-find parent index key in some index, or cache lookup failed, or found multi-exact 123 from before rel min mxid 456, or could not locate a valid checkpoint record. And the thing to notice about all of these messages is that they seem to be complaining about something which is internal to the system. It's very different than an error message that says something like, well, that table doesn't exist, or you're trying to violate a foreign key constraint. Because if you get an error message that says that a table doesn't exist, the most likely reason why you're getting that error message is because you specified the name of a table that doesn't exist and probably never existed in the system, or a table that someone has dropped. You're not finding the table not because of anything about the database being wrong, but because of something that your application is doing. And similarly for things like unique index violations and foreign key violations. Those are typically just the result of whatever the application behavior is, and they don't indicate any kind of problem with the database itself. But these error messages that I'm showing here are different, because these error messages are all talking about internal things. The status of a transaction with a particular number, a block in some file that's managed by the database, some kind of thing that's internal to an index, a cache lookup failure. It doesn't really matter whether you know what these things are specifically or what they refer to. Certainly, if you want to know what one of these things refers to, you can talk with your PostgreSQL support provider if you have one, or make an arrangement with one if you don't have one yet, and they may be able to explain it to you. But even if you don't have access to that information for whatever reason, you can still sort of understand that these don't seem like complaints about things that the user did. These seem like complaints about something that's inside the system. And that's a clue that perhaps you've got a corruption problem. So if you do have a corruption problem, what do you do about it? Well, the thing you should try to avoid doing is you should try to avoid fixing the corrupted database. You should look for some other alternative. For example, if you have a master and a standby, and the master seems okay, but the standby has a problem, don't try to fix the standby and put it back into service. Just rebuild the standby. Get rid of the database cluster that's currently on the standby. Do something about any hardware problems that may exist on that standby, and then reclone from the master and create a new standby. Or if the problem is only with the master and you have a standby that is unaffected, then maybe you want to fail over to that standby. Or maybe you can restore the master from backup. Another option that's viable for some people is to rebuild the data from some other source. For example, if you're using your PostgreSQL database as a reporting server where you import data from other sources into PostgreSQL, and then you use PostgreSQL to run reporting queries, you don't really need to fix your broken database. You can just get rid of it, re-import the data from the original source into a fresh database, again, after correcting any hardware issues that may exist, and then you're in good shape. But sometimes none of that is possible. Sometimes you only have one copy of the data and that copy is corrupted. Or sometimes you have multiple copies of the data, but you find out that they're all corrupted in the same way. And so in that case, your only choice is to try to get some data out of the damaged database. I feel the need to insert a disclaimer here. If you decide to try to extract your data from a damaged database, I really encourage you to proceed with great caution. Asking for help is not an admission of weakness. It's just a really good idea when you're dealing with a complicated technical problem. I also want to say that, as with any talk that I give, the advice that I'm about to give you is based on my experiences, and I hope that you may find it helpful, but I'm not promising anything. So if you try the stuff that I'm about to explain, you do that at your own risk, and you may lose your data, you may further corrupt your data, and I don't want to be responsible for that. So just a disclaimer before we go on. So that being said, the basic idea here is that you're going to do two things. First of all, before you do anything else, you're going to take a complete backup of the damaged database cluster. You want to copy every single file from that database cluster to somewhere else, someplace safe, someplace where it's not going to get lost, damaged, or modified in any way. And the reason why that's so important is because your attempt to recover the data may make the situation worse, possibly much worse. And I think as you see some of the things that we're talking about at the next couple of slides, you may understand why that is such a large danger. But there are even more dangers than the ones I'm going to discuss here. It's very, very easy in the process of trying to recover data from a corrupted database to have additional damage occur. And you want to at least be able to get back to the state that you were in when you began trying to recover your damaged database. So make a copy. Now, once you've done that, your goal should be to use pgdump to back up the contents of the database and then restore those database contents into a new database created by a new initdb. Sometimes a person who's in this situation of trying to fix a damaged database will want to just kind of hit the database with a big enough hammer that it starts running again and then put it back into service. And I strongly recommend against that approach. Because even if you seem to have fixed the most obvious problem that you have, it's very easy for the same thing that corrupted the database originally to have created latent problems that will not manifest themselves for some period of time, possibly months or even years. So you don't really want to be in a situation where you have a corruption event and then you think you fixed it, and then 6 months later, your database goes down because of some latent problem that you didn't realize when you were trying to conduct a repair. So I strongly recommend that if you have a corruption event, you do go through a dump and restore process. But the problem is that's not necessarily super easy to do. And one problem that you might run into is that you have a database that you cannot start. If you can't start the database, then you can't run pgdump. And so then you won't be able to do what I just described. So in that case, you need to get the database to start somehow. And there is a tool called pgresetwall or pgresetxlog that will very often allow a corrupted database to start. It will not fix your database. In fact, your database will probably be more corrupted after you run pgresetxlog than it was before you did that. But it probably will start. This does depend on exactly why it won't start. So just to provide a little bit of clarification, the most common reason why you end up using this tool is because you lost all of your wall files and you don't have any way of recovering them. If there's nothing in pgwall and you try to start the database, it's not going to work. You need to have those wall files. So hopefully you do, but if you don't, pgresetwall will allow the database, again, to start. It will also help you if you've lost pgcontrol or pgcontrol has been corrupted and you don't have a way of getting back to a good version of that file. There may be some other circumstances in which this tool is useful as well, but you really don't want to overdo it. This is a big hammer. And again, its only purpose is to try to get the database to start up. It will not fix anything else that's wrong with your database. In some cases, you may have a database that is so badly corrupted that there is no hope of starting it. For example, you might have lost the entire database except for a handful of files. And if that has happened to you, you're never going to be able to start the database pretty much no matter what you do. In that case, you may want to look into an open source tool called pgfiledump. It was originally developed by Tom Lane when he was at Red Hat, and it's still being maintained by other people now. And one of the things that those people did is in newer versions, it can recover data from raw files without needing a running server. So if you have a database that's so badly damaged that you're never going to be able to start it up, then that may be useful to you. Now, if you get the database started, the next problem that you might run into, or one of the next problems you might run into, is that you might not be able to successfully dump the database because pgdump might fail. pgdump has various internal sanity checks built into it. And on a corrupted database, sometimes those sanity checks can fail because the state of the database isn't very sane. And if that happens, then you need to find some way to work around the problem. One really powerful technique is to just drop stuff. If you are having a problem with a temporary table or an unlogged table, or maybe with a stored procedure or something else that doesn't contain critical data that you really need to have, consider just dropping that object. Remember, you made a copy before you started all this, so you can always go back to the state where you had that object and try to do something with that specific thing later. But dropping stuff that's making the dump fail is a very powerful way of getting the dump to succeed, and it very often works. Another thing you can do is reindex an index that can't be dropped. For example, if you have a problem with a system index and the system index has a corruption issue that is causing pgdump to fail, then you might consider reindexing that index. You can't drop the index because it's a system index, but you could reindex it. And there are other situations as well where you can work around problems with index corruption by reindexing. Another thing you can do is, instead of trying to dump the entire database, you can try to dump individual tables or schemas. And sometimes that will succeed where dumping the whole database fails. If a dump of a particular table is failing, then the whole idea of using pgdump is something you're going to have to give up on. But you might be able to extract some data from that table using a select statement. There's a hidden column called ctid that represents the physical position of a tuple within the table. And filtering on that column can be very helpful because you can try to pull out specific tuples by physical location, or you can try to exclude certain tuples that you know are corrupted by physical location, and then just try to get the rest of the data out of the table. One other thing that I can recommend if you are having trouble getting pgdump to work on a database that is running is to use a utility that Enterprise DB publishes called pgcatcheck. This is a little open source tool that we have up on our GitHub, and it's useful for diagnosing catalog corruption because it will run through all of your system catalogs and look for stuff that seems to be messed up, and it will print out a bunch of messages that will tell you about exactly how things do not seem to be correct. I helped design this tool. I helped write this tool. I don't know whether you'll find it useful. I find it quite useful. It tells me what I want to know, but I'm not 100% sure whether it will tell you what you want to know, but I hope it will. I think it's a pretty cool way of finding out exactly what's wrong with your system catalogs, and in particular, how widespread the problems are. Like when you start to run pgdump and something fails, you may wonder, do I just have a problem with one of my tables, or do I have like 600 instances of this problem? It could be either one. You may not know. And if you run pgcatcheck, there's a pretty good chance that you'll find out which one it is. And that can help to inform the strategy that you choose to pursue in recovering your data. Now, you may think that if you get the database to start and you manage to run pgdump, then you're out of the woods, because now you've got all of your data in a text file. And so what can possibly go wrong at that point? But it turns out that even once you reach that point, you can still have problems. And the reason for that is because the dump can still contain logical inconsistencies. There can't really be anything physically wrong with the dump because it's just a text file. It can't have bad metadata or whatever the way that the running database system can. But it could have, for example, duplicate rows in duplicate values in what's supposed to be a column with a unique index, or it could have foreign key violations. Of course, unique index violations and foreign key violations shouldn't happen in a database, but in a corrupted database, anything's possible, and so you might have those kinds of problems. And there's no automated solution to those problems. It's just a question of a human being needing to look at it and decide what to do. If you have two records where there should only be one, You could merge them. You could delete one of them. You could renumber one of them. Who knows? Somebody who understands what the data is supposed to mean and how it's intended to be used will need to look at the data and make an intelligent decision. But if you get through all of these steps and you get the database started, if it wasn't running already, and you dump out your data and you restore it into a new cluster, then there's a good chance that you will probably have most of your data back and you'll have it in a cluster that is in good shape. And so then as long as you make sure to also investigate why the data corruption happened and fix any underlying problem that led to it, you should be in pretty good shape. All right, thank you very much. Thanks for coming to the talk. I believe we have a short Q&A session after this. So looking forward to any questions, and thanks a lot.
Okay. Welcome, Robert. Thank you very much. It was very clear talk, and I
Thanks.
enjoyed it. I think you have already covered all the questions in the chat.
Yes, I think so.
Don't you want to comment on? I also didn't know that we can enable checksums on standby. That's actually seems suspicious.
I actually didn't realize that that was possible either. I'm kind of surprised that full page writes doesn't mess it up, but I guess it doesn't. Because I'm sure Mikhail knows what he's talking about.
I have a question. How often do you actually try to manually recover the corrupted database? I know this is the last option, and usually you want to just take your backup, whatever freshness it is. But how often do you fire up Hex editor and try to?
I actually never go as far as hex editing the database, or almost never. I mean, I might have done it once or twice, but having to use pt reset xlog and then fix whatever makes it not dump and then do a dump and restore. I mean, it's pretty common. Like it doesn't certainly happen to me every day or to EDB every day, even with the number of customers we have. But I mean, there's definitely at least a case every month or two with some customer. I think there's a lot of ways to mess up your database or to have your database get messed up. And you know, if you have enough customers, then people will do it all the time. So
Sure.
I think it's very rarely necessary to go down to the level of trying to recover individual pages, or at least it's been my experience that that's very rarely necessary. But you know, having people who remove their wall files or mess up the backup and restore or have a disk fail or something like that, those things, they don't happen every day, but it's pretty regular.
Okay, thank you. We have a question in the chat. Can dropping corrupted objects be more risky? Is it safe in common case?
Well, the big risk is that you're going to lose the object that you drop. So, you know, hopefully you have a backup of your corrupted cluster, so you're not losing it permanently. But you know, it will be gone, right? If the drop succeeds. I have not personally experienced a case where dropping a corrupted object made things worse for the rest of the database. I guess one exception to that is there is a parameter called zero damaged pages, which I did not talk about in this talk, and I recommend that you never use it. Because every time I've tried to use it, I've made things much, much worse very, very quickly without intending to do that. So I don't think that's actually a good solution to any problem. But if you activate that setting, then doing practically anything to the database can cause more of your data to disappear, which is really bad. But apart from that, I don't think it's particularly unsafe to drop objects, except, of course, for the objects that get dropped. You know, it's very unsafe for them.
I wonder, when you have disk corruption, do you have a statistics of which size the corruption has? Is it one sector, or how it goes?
Mm, I don't think it's usually one sector. I don't have statistics. I think it would almost be meaningless to compile statistics because there's so much variation. I definitely have seen examples of customers who have, I think of all the cases that I've tracked down personally, the least corruption I ever saw was somebody who had 2 bytes of corruption in one data page. And as far as I could tell, everything else in the entire database was fine, but somehow the info mask field of one tuple got overwritten with garbage, and the tuple became unreadable as a result of that. So that was the smallest amount of corruption that I've ever seen. And small amounts of corruption are actually pretty common because, if somebody does something like remove all of their wall files, they are often doing that on a database that's not very important. And that's why there wasn't some kind of safeguard in place to make sure they didn't remove all of the wall files. Well, if you run PG reset wall or PG reset xlog on a database that wasn't doing very much, or maybe wasn't doing anything, after losing all the wall files, you're probably not going to have very much corruption. You certainly might have some, but it's probably not going to be all that serious. And if you do a dump and restore afterward, chances are good you're going to get back all of your data without any really big problem. But I have seen cases where databases are extremely severely corrupted, and that usually happens when the thing that is causing the corruption is left unaddressed for a long period of time. So if, for example, you're doing your backup and restore procedure wrong, and you do a lot of backups and restores over and over and over and over again, then the problem just gets worse and worse and worse and worse and worse because you haven't treated it, you haven't corrected it. I've actually seen 2 different examples of customers who did exactly that thing and ended up with really, really severely corrupted databases. I think the same thing could also happen due to a hardware problem where the issue wasn't addressed for a long period of time. Yeah, but I think those cases usually get reported a little bit faster. It's more common, I think, when somebody has a hardware problem or hits a bug. They tend to notice those cases a little bit faster, whereas the cases that are caused by not being careful about administration, it's easier for that to be a problem that kind of goes on because the lack of careful administration can also hinder noticing that you have got the problem once you've had it. But it comes in all varieties. I mean, I've seen ZFS induced corruption where there was a pattern to the corruption, but it affected basically the entire database or like large chunks of the database. So I've definitely seen severe cases of corruption that were software induced. But yeah, the really severe cases generally involve doing something bad over and over again rather than just once.
Okay, thanks. By the way, we have a question about ZFS. Can we use full page? Can we turn off full page writes on it?
Nope.
Right.
Next question. You can't turn off full page writes. It doesn't work. You will get corrupted option. And at least in my experience, using ZFS will also give you corruption. So if you have ZFS and full page writes turned off, you have 2 potential sources of corruption. I don't know. I don't want to be too hard on ZFS. It might be safe in some configurations, but I've seen several customers who had incredibly bad experiences with it that were pretty clearly due to ZFS and not anything else. So I've become very skeptical of it. There may be people for whom it works great, and I just never hear from them because they don't have any problem. But I've heard from some people who did have problems, and they were caused by that, and they were very, very bad problems. So I would not want to put my data in it on the basis of what I've seen. And I definitely would not want to turn off full page writes. Of course, he's now asking why, which is a great question. the big thing is that the buffer the buffer pool for Linux, the in-memory buffer pool, uses 4K memory pages, and Postgres uses 8K pages. So even if at the level of your disk there's no problem with torn writes, you can get half of a page written to disk and not the other half, because as soon as Postgres writes the data out to the operating system, the 8K page that it has internally gets split up into two 4K pages in the operating system buffer pool, and then you can have one of those pages be modified and get written down to disk in the modified version, and the other one doesn't if the system crashes at just the right time. Even if everything down from the buffer pool layer all the way to the disk is atomic in 4 kilobyte or 8 kilobyte or some larger units, which is, I mean, maybe it's the case, but even if all of that's true, you're already dead by the time that Postgres wrote the data to the operating system pool, buffer pool, and so nothing after that actually matters. You can't fix that problem once it's happened.
Okay. You have also mentioned that you have seen a couple of times memory corruption issue. I wonder how it looked like, because recently we had what seems like a memory corruption issue with one customer on a very big machine, and it looks like it is a cache coherence problem.
Oh, interesting.
The corruption size was 46 bytes, and our hypothesis is that it occurred while moving memory page, a cache line between two NUMA nodes.
So that's really interesting. I haven't seen a case like that myself. That's a cool story, though. I'd be interested to hear more about it if you find out more about what happened. The cases where we saw it at EDB were years ago now. There were two cases that I can remember, and they were separated by a number of years, but they're both old. So I don't remember the exact details of what happened. I'm pretty sure that in at least one of the cases, the machine got really slow, in addition to the data being garbled, and so the speed impact of it was part of the tip-off that eventually enabled tracking the problem down. But unfortunately, my memory of all of this is just not current, because it is pretty uncommon. When something goes bad, it's usually something related to the permanent storage rather than the memory. I just wanted to mention the memory in the talk because it can happen. You would think that if your memory were corrupting data, the whole system would just go down and you would be offline. And I think that's probably often true, but there are some cases where you have marginal corruption in memory, where like you have a small percentage of your physical memory that is lightly corrupting the data, and a small percentage of the bytes on the page gets scrambled every time it passes through there, and that you can actually survive running with for some period of time. I think that kind of problem is very hard to run down. Fortunately, it's also very rare.
Okay. Thank you very much. I think it's our time to.
Okay. Thank you.
To finish.